Welcome and hello. This is a video lesson in MODSIM, and in this lesson we're going to be talking about custom runs. This is a way to customize your MODSIM using code. So if you go up to MODSIM in the menu, click on Custom Runs, this will bring up the code editor, which we'll be talking about in this lesson. Custom code can interface with MODSIM at any location, including data input, execution at the start of any time step, processing at intermediate iterations, and at model output. So in this lesson, we're going to talk about how custom code can interface with your model, and I'll describe it, do a quick demo, and then modify an existing model using the custom code. All right, so let's go ahead and get started. As you just saw me do already, go up to MODSIM and Custom Runs. This is the menu item that's going to open up your custom code. Along the top, we have the menu items File, Tools, and Help. And then, so File is basic file management tasks like open recent, new, open, save as, exit. There's also this compile and run, which we'll see in the demo phase later in this video. Tools, this is tools options. It talks about just the different tools within the interface. It's a little bit too detailed than I want to go into for this lesson. And then help, this is actually something we'll talk about more. This opens up the library of different object elements that are accessible to the user when writing code. This is the main code area. As you see, we are already started off with a boilerplate code sample right here, which is what we'll use. But if you wanted to create a new file, you could just come up to File, New, and then it'll start you off with a new code file. Now, I have not saved this file yet, and when I do, it'll be saved as either a C# file or a VB file. Those are the two options for our programming language. So this is what you're seeing here is C#, and then I can select VB.NET, and it's basically the same thing, just different language. Over to the right, we have different library references and then our nodes and links based on the current network. So we have 1, 2, 3, 4 nodes. And if I expand nodes, I see those nodes. Okay, so they're categorized first. So there's 1 demand, 1 sync, and 2 non-storage nodes. I'm going to go ahead and start by discussing the help menu. We're going to sort of take a tour of the different code elements and objects and classes and fields and properties and everything else by checking out the help contents. That's going to open up this box right here, where it starts with an overview showing our namespace. This is the one and only namespace that's used in MODSIM. It's csu.modsim.model. That is the namespace that's called right here on line 2. We should say it's imported. And then down here in the namespace library, we can expand, open up that namespace. And now we have a list of classes, enumerations, structures, and delegates. This is in the Contents tab. If you click on the Index tab, you can search for a keyword. So for instance, link. Here is the link class. So I can just double click on that. It gives me the information about that class or any other search term that I find. Over in the Search tab, it's a similar idea. This is for objects. So let's just type in demand. It gives me a number of matching searches that have the word demand somewhere in there. So if I click on list topics, that's what I did already by clicking enter, and then display, it'll actually cycle through where it says demand in each of these results. So it's a little bit less of a direct search than the index method. It's just a different type of search compared to the index tab. All right, let's go ahead and take a look at the boilerplate code that's presented for us right here. You can also resize parts of this box. It's mobile, it's resizable, and that's sometimes helpful if you need to see more or less of a different part of this user interface. All right, at the top are some generic imports. After that, we have the main function, which is called right here. It's a main subroutine because that's just what it's called in VB.NET. Inside the main subroutine, there are handlers for controlling events that are triggered by inserting code in the various subroutines. So we have different event handlers here from lines 10 through 16. And what's happening is when the my model, that's the object that we define right here on line 7, as an event init, then it's going to be calling this on initialize subroutine, which is defined right down here. Now, this on initialize subroutine currently has nothing inside of it, so nothing's going to happen. Same is true with all of the other events. So let me make this a little bit wider. We have an on iteration bottom, on iteration top, on iteration converge. Those are the names of these subroutines defined further down here in this file. All right. So after those includes, we also have line 18 here loads the model object from the file, and then line 19 runs the model. All right. So that's the end of the main routine. You can run your normal model just by going up to the play button or MODSIM, run MODSIM, but you can also do so by going file, and then run the same way. Now, since I haven't made any changes, there wouldn't be any differences. But what I'm going to use this code editor for is to run the model without code changes and then make some code changes, run it again, and then just confirm that the code itself was able to modify the actual input data and hence the results of the model. The documentation that I used for this lesson is right here. It's not the main user's manual, but it's the MODSIM 8.1 tutorials and examples network. So part C, there's a table of contents right here. There's tutorial A, tutorial B. I'm looking at tutorial C, where it talks about the code in general, customization of MODSIM, and provides a few examples. If I go down to page 93 of that PDF document, we have a diagram that sort of demonstrates the overall workflow or work process of the MODSIM simulation. It starts up here at initialize. So the initialize function is called one time. What I mean by that is on initialize subroutine right here is called once at the very beginning of the simulation and never again. So on initialize. After that, you can see that the time steps start to iterate starting at 0. So here's time step 0. The next time step is time step 1, time step 2, and so on. Within each time step, there is an iteration, which is 0, 1, 2, and so on. So the numbering starts at 0. And then within each iteration, there's going to be a iter top event, iter bottom event. Then the solver runs and then it checks for convergence. So why I'm bringing this up is because this init event is raised once. Then we have iteration top and iteration bottom, which is here and here, which occurs once during the iteration. And then the converge right down here after the solver, that's this one right here on iteration converge. And then on finish occurs when all of the time steps and all the convergence has taken place. This on converge, iteration converge, I believe only is when convergence is successful and the value here is yes. Because if an iteration does not converge, then it goes on to the next iteration and then the next iteration until it has converged, in which case the routine advances to the next time step and starts with the first iteration, and so on and so forth until all the time steps have completed, in which case the on converge event is raised, which occurs only once, just like on initialize, except at the end of the routine. And then finally, MODSIM is done running. All right, let's go back to the MODSIM help menu. So help, contents, and then let's check out the namespace TSU. Now inside the classes, that's where we have information for the links and the nodes and the time manager, time series. These are all names of different classes. In addition to the classes, we also have a list of, let's see here, scroll down, enumerations, structures, and delegates. So in this second column for the description, it tells you what the class is all about, sort of in a single sentence. Links. The link class contains all the generic information for a link in the MODSIM network. But then further down, mlink contains all the information for a link that will be used in the model that can be edited in the graphical user interface. You may be more familiar with some of the parameter values in mlink. Let's go ahead and check out what some of them are. So if we click on link, for instance, and then expand and click on some of the fields, we see there's a description for the link. That's optional. And then there is from, that is the node that the link starts at. Down here, there's to, that's the node where the link ends at. There is this M right here. This contains most of the information about the link. It contains the link data for the model that is edited and available in the graphical user interface. And then mlink class, which is right here, let me open up some of the fields. What we have is the cost. So you're well familiar with the link cost, right? That's just this value right here. There's lag factors that is associated with routing, loss coefficient that's associated with seepage. There's max constant and max variable. That's the maximum capacity in the link. Minimum, that's constant. So the max could either be constant or variable. And then the type of value, if you just like click on the individual field name, it'll tell you the cost is an integer. So that makes sense. Let me click back. But as for lag factors and loss coefficients, those would be arrays of floating point numbers, I believe. So let's click on lag factor. It tells us lag factor as single. Oh, so in C sharp, it's called float, but in Visual Basic, it's called a single, I think this is called single point floating variable. So basically the same thing as a float. All right, so all that information is contained in this documentation. Just like mlink, there's also an mnode. So let's take a quick peek at that, then expand to show the fields. The first one here is ADA demand, it's M. This is demand time series as entered in the interface. So keep in mind, nodes is referring to non-storage nodes, demand nodes, reservoir nodes. There's more information in the nodes simply because there's different types of nodes as opposed to a link, which is a little bit more singular and generic. So for this field ADA demands M, that'll only occur in demand nodes. However, the next field down, ADA evaporations M, this is evaporation data, which you'll only see in the reservoir type of nodes. The user's manual or the tutorials and guides PDF file groups the different classes into these different types. So pre-processing would be like the mlink and mnode time series class. Runtime is for mlink, mninfo, and time manager. Post-processing involves the model output msdb class. All right, let's go ahead and run a model and just kind of demonstrate how this works by watching a model run the normal way. Then we're going to add some code to modify the model just slightly. Then we're going to run the model again with that modified code. All right, so I'm going to close this custom code editor. I'm going to show you what we have in the model right now. Right here at NS1 on storage node 1, we have a constant 50,000 acre feet per month of flow. That's entering the system. That's the inflow. And then demand node D1, this has an increasing demand from 30,000 acre feet per month up to 85,000 acre feet per month. So what happens is we're going to have plenty of water up until 50,000 acre feet per month. And then after that, we're going to have a shortage because there's a constant 50,000 acre feet per month entering the system. Let's go ahead and save and run. All right, that ran. Let's take a quick peek at our results. Here is the plot. Right here is the demand. So we saw that increased from 30,000 up to 85,000 over the course of 12 months. And then we have the surface inflow, a constant 50,000 acre feet, which can only supply up to 50,000 acre feet. The difference over here in the first 4 months is just leaking down through the sink. There's no extra benefit in supplying demand node D1. And that basically means we have a shortage, which is this plot right here. The shortage begins in June, and then it just increases 5,000 acre feet per month. And so what we want to do in this example is to decrease this demand D1 by 20,000 acre feet per month each month. So instead of starting at 30,000 acre feet and going up 85,000 acre feet, the custom code we're going to write is going to make it start at 10,000 acre feet and then increase at the same rate up to what will be 65,000 acre feet, in which case we'll still incur a shortage, but it will only be for like the last 3 months of the year. So that's what we expect to see. Let's go ahead and get started on that code. So let's go MODSIM and then custom runs. Okay. All right, there's a few different ways we could do this, but what I'm going to do is just use what the user's manual gave me as an example for the first example, or the tutorials and guides, excuse me, is to add some code inside this on iteration top routine right here. So I'm going to go down to on iteration top, which is right here. I'm going to give myself a couple lines. I have the code already prepared and copied to my clipboard, so I'm just going to paste it in and then explain it. All right, so what I have here is comments every line. So this right here is just a comment line. This is the actual executable code. This is another comment. Comment in VB is just a single line comment with this single quote right here. So what we're doing here is we're just saying if the iteration number equals 0, meaning we don't need to reset the demand every single iteration. We're declaring a variable for the demand node, that's m underscore demand node. And then later we're assigning that demand node to the node D1. That's the label for this node. Above that, we have the time step index called current index. Let me go ahead and move this over so you can see all the text. And then finally, the last executable line of code here takes the current demand, which is right here, and then it subtracts 20,000, and then it assigns it to our demand node. So this line right here down below that's commented out, this is sort of the long form way of doing the same thing. This what we're actually executing on line 40. This is more the shorthand way of doing it by just going negative equals as opposed to subtracting 20,000 from this value right here. So I'm going to delete that so it's not confusing. The user manual also mentions that this 0 right here is sort of a default placeholder 0 in case you're using hydrologic states. If not, just leave it as comma 0. But if you have multiple hydrologic states, you can modify the demand for each of the hydrologic states. This 0 would be the hydrologic state index. All right, so that's all we need to do there. Let's go ahead and save and compile and run. So to do that, we'll go up to the File menu and then Save As. Okay, here is my project. This is the same directory that the .xy file is saved in. So I'm going to name this b-20k.vb, right? Oh, this needs to be a .d. Oh, I see the problem. Okay, so I almost this is the C# syntax. I'm going to go ahead and just paste this exact same syntax into bb.net. Okay, that looks more like it. And then go down to my on iteration top and paste that in. Okay, so that almost saved with the wrong syntax. That wouldn't have compiled, that's for sure. So file and then save as. And then for file name, d1 minus 20k.vb, since it's going to be 20,000 acre feet per month less at d1 than initially assigned. And hit save. And then let's go up to File and then click Compile. So, no. Okay, so it compiled, and down here in the message box, it says that it has built with no errors. That's good. If you do have any errors, then it'll mention it down here in this message box, and it'll tell you, what the line number is, what the error is, and that should help you pinpoint what the problem is. All right, so with that done, I'm going to go up to File and then Run. Let that run. Okay, so that just took a few seconds. And let's check out our results. So let's check out the demand data, right click and graph. All right, very cool. So these are the results I was hoping to see. I'm going to expand D1. Here is the demand in light orange I've highlighted. Like now it starts at 10,000 instead of 30,000. It increases at the same 5,000 acre feet per month, each month ending at 65,000. The surface inflow, which is still 50,000 acre feet per month, which is why can't go above 50,000 acre feet per month. And then the shortage that we expected to see starts right here for the last 3 months of the year. One thing to mention is when you're running your custom code, it has to be invoked in the custom code editor by going up to File and then Run. So say, for instance, just because we have a .vb script that's saved in the same project directory doesn't mean it's going to be called. In fact, it won't be called. If I click on the Run MODSIM button here, or if I go to MODSIM and Run MODSIM, it's not going to integrate that .vb script. So now if I look at the results right here, we have the same results we saw originally without the decreased 20k acre feet per month demand, right? This should look like the same demand that we saw originally, starting at 30,000 and then going up instead of the modification we made using that custom code. All right, well, that was it for this lesson. What we talked about was how to add custom code to our MODSIM by going up to the MODSIM menu and custom runs.